Marc, Nader, and Melhem El Helou. The moderator of this panel is a seasoned business and technology executive based in Toronto, Canada, with a proven track record of leading organizations through new strategies, mergers, and acquisitions. He has over 20 years of experience in business, operations, network, and IT disciplines. Please welcome on stage the Chief Operating Officer at CaptoCloud, Mr. Raymon Lahoud.
Good afternoon, everyone. Thank you for the kind introduction. I want to take the opportunity to talk about also I'm a member of LebNet. LebNet is a non-profit organization for technology professionals in Canada and US from Lebanese descent. I would encourage you to check our social media webpage. And this is the reason I'm here right now highlighting this. I've been in Canada for 26 years. I left when I was 18 years old, and I did my university there. And recently I joined LebNet and gave me the opportunity, when I come visit my parents, get the chance to meet all kind of, professional, intelligent people that I'm excited about. So a little bit, I want to give a credit to LebNet for, connecting me with this great audience and great team here. So, we talked this morning and we heard from everybody around application and devices. Bottom line is there is a network infrastructure that is going to connect between those devices and application to make IoT works. It's a full ecosystem is required to work. And this is today, right now we want to talk about it. And in my mind, this is the core part of the IoT. Recently, we have seen a lot of evolution in technology, new technologies coming on board to allow us, to enable us to build that IoT infrastructure we need to get smarter and smarter about the way we do business, improve our customer experience, and improve our well-being. So, from an IoT implementation, some of the characteristics we need is really about low bandwidth. We need wireless deployments for quick deployment. We do definitely need some cost. We have to keep in mind the cost of deployment, as well as reliability and security. These are all aspects that need to come together to deliver a network that's going to allow us to deliver that ecosystems from end to end. I'm going to take right now, I'm going to hand it, and I'm delighted to be the moderator here, and I want to hand it to my distinguished guest here and panelists here to introduce themselves. Marc.
Yeah. Good morning, good afternoon, everyone. So, but thank you for saying that late. I hope the discussion today will be interesting for you. So, my name is Marc Nader. I'm in charge of operations of Data Consult. Data Consult is a solution provider focused on digitalization technologies, and we have an IoT practice now for the past 4 years. We are based in Lebanon, but we are also present. We have local offices in Syria, in Jordan, and in Saudi Arabia.
Good afternoon. My name is Antoine. First, I would like to thank the organizers for organizing such a nice event. IoT Lab, its 7th version. Welcome to this panel. I work for the Ministry of Telecommunications. Since 28 years, I have a large portfolio background in telecom, fiber, switching, and since around 10 years, I've been assigned in the ministry as the head of national transportation services, with responsibilities covering licensing, spectrum, equipment importation, mostly.
Thank you everybody for attending our panel. My name is Jubran Ayan. I am the head of radio at Connect and Waves. Connect is one operator in Lebanon. At Connect, we have built a network of 300 sites, approximately, which is the third largest in Lebanon after the mobile operators. Before Connect, I used to work in Nokia Siemens, where I used to be the lead designer for LTE. I participated in deployments in Europe and in the Far East. Before Nokia Siemens, I used to work in Motorola as a lead designer for the WiMAX and 4G as well. And before that, I used to work in Siemens AG in the field of GSM core networks. Thank you, everybody.
Good afternoon, everybody. My name is Zogheib. I am the Product Management Director at GlobalCom Data Services, which is a large telecom operator. Includes several telecom companies, of which I can name GDS, Siberia, IBM, Cablevision. We've been in the telecom market for like 25 years. We specialize in internet services and in the wireless data connectivity. GDS is the operator, privately held micro operator in Lebanon, connecting banks, corporate. And we are looking into deploying an IoT network to cover all Lebanon so that all stakeholders and solution builders and customers can benefit from to connect their devices and have a more efficient operation. Thank you.
Good afternoon. I'm Melhem El Helou, Assistant Professor of Computer and Communications Engineering at the Central University of Beirut. And my teaching and research interests are in the areas of wireless networking and Internet of Things. In fact, IoT is at the heart of our strategic plan at Zogheib, and since 3 years we teach the upper courses on IoT technologies. The objective is to provide our students with the knowledge and skills that are necessary to design and to build an end-to-end IoT chain. And our students have the opportunity to explore and exploit a live LoRaWAN network that's deployed here on campus. We are also will be offering, starting next June, continuous education on IoT for professionals. This training will touch on both theoretical and practical issues. We're also preparing a massive open online course on IoT to address a wider community. And most importantly, we are preparing a master's program on IoT. What is original about this master is that we are reaching out to collaborations with industries and with the research lab so as to build a common vision on the future of IoT and to fill the gap, try to fill the gap for IoT assets. We also conduct a research activity on IoT addressing both theoretical and practical problems. For example, coverage planning, capacity planning, and security-related issues. We are able to share our results through tutorials in international and local conferences, through scientific publications, and also through hackathons, as the one that took place here on campus yesterday. I'd like to mention that we have also collaborated with Lebanon and CaptoCloud to deploy the first smart agriculture network in Lebanon. The objective was to really monitor growing conditions at CaptoCloud, which is one of the most famous vineyards in Lebanon. Thank you.
Thank you. Thank you all for the introduction. So we're gonna keep it, the conversation here, and also we will take questions at any time. That's okay with the panelists. But before we get into the discussion, I want to give, since you're the last one to talk, maybe you could give us a little bit of high-level summary because we've been hearing a lot of terms, IoT, NB-IoT, LoRaWAN, and other protocols that's been used. You want to give us a quick academic view of those before we open the conversation to bring everybody up to speed on this technology?
Yes, exactly. IoT networks have become heterogeneous. So as you said, I totally agree. We've heard about a lot of technologies like RFID, CP, Bluetooth, Wi-Fi, going to LoRaWAN, and IoT, Sigfox, and engineering. From an academic perspective, I guess an important question is, are these technologies competitive or complementary? Or in other words, will we have one day a unique, flexible IoT technologies, or the landscape will still remain heterogeneous with diverse technologies that can be covering the same area? From a technical point of view, the IoT technologies differ in their frequency carriers, coverage, data rate, latency, so quality of service, power consumption, device complexity, network cost, and time to market. For example, NB-IoT and LTE-M operate in licensed spectrum, whereas LoRaWAN and engineering operates in unlicensed spectrum. We have technologies like Zigbee, Bluetooth that are limited in coverage, others like Sigfox and IoT that can reach areas up to 10 to 40 kilometers. We have also technologies that are limited in data rates, such as LoRaWAN, Zigbee, others like Wi-Fi, like mobile networks, 4G and 5G networks that can provide higher throughputs, higher bit rates. Also, NB-IoT leverages and reuses existing technologies, while LoRaWAN, for example, requires an infrastructure. So I guess each technology or IoT technologies are really heavily mapped to specific requirements and to specific use cases. If you go back, for example, to smart agriculture, devices that can be large areas. Devices actually operate under certain power consumption constraints and just need to send a small amount of data from time to time. In this use case, a low power, low range technology could be a good fit. If we take the example of smart buildings, here probably we may need higher data rates, but we have less stringent coverage conditions. So I guess there is room to diverse IoT technologies. So in my opinion, in the time being, we'll have IoT technologies that be coexisting, and probably an example to prove it is that Orange now in France is deploying LoRaWAN and LTE-M, and s.a.l is deploying Sigfox and LIT. So operators are thinking of deploying both technologies exactly to try to meet different use cases and try to respond to different use cases.
Thank you for the quick summary. And really, just to re-summarize, is the technology, all technology has pros and cons, goes back toward how to develop a solution to meet the customer needs and the needs of the requirement to deliver services in a reliable, secure way. You mentioned the spectrum, licensed and unlicensed, and as I highlighted earlier, I don't live here. And I'd like to maybe, Antoine, give us a little bit of your input of, what's licensed, unlicensed, and what's the regulation around deploying wireless technology.
Okay. According to the applicable laws so far in Lebanon, Lebanon is still a closed system. So the Ministry of Telecommunications owns the spectrum. It's not open yet, okay? Until it is privatized with the TRA and Lebanon Telecom and the execution of the law 431, the Ministry of Telecom owns the spectrum. So there is no licensed and unlicensed band. All the frequencies have to be licensed from the Ministry of Telecommunications. But the Ministry is aware of the different devices, home devices, that requires those what you are calling unlicensed frequencies or ISM bands. So whatever equipment you have on 463 MHz, 868 MHz, Wi-Fi 2.4, 5.8 GHz, these are based on minister decision allowed to be used for low power. So it's like a Wi-Fi router or remote control for garage or for your home devices. This is how you can use them. But if you want to build a network, you want to build a commercial network, you'll have to go through a license. Okay. Nevertheless, if you have, for example, because we are talking here about IoT, in your premises, in your farm, limited geographical area, private area, you can build it, you don't need a license for that. For example, in a farm, you monitor your cows, in a specific vine farm, for example, also, they want to monitor the soil. If it is a private space, you can do it, you have no issues. But if you want to build something like nationwide network, you need a license. And for that, the Ministry of Telecommunications and OGERO are aware of this. And for that, OGERO, since 3-4 years ago, started by launching an RFP, started with an RFI, in fact, for LoRaWAN network. And we have, back at that time, 4 finalists for the RFP, but the RFP didn't continue. We have done 2 pilot tests. One you have mentioned earlier with Lebanon and Artifraya, and the other one was data consult in Beit Misik. One is related to agriculture and the other one to smart cities. Also, we have another pilot project, but it was not implemented, related to smart parking with another company. For the meantime, we are reviewing our RFE, and hopefully it will be ready by the end of Q2 2019. We launch it maybe in June, July 2019 to build a nationwide LoRa network for OGERO. Okay, and this will be used. It's an open platform that can be used by anyone who would like to build any vertical application. Also, since IoT uses data transmission, so it needs a data network. We have already about 8 licensed data network operators, like GDS and Waves are 2 of these operators. So those operators, since they are already licensed for data transmission, IoT is a small packet of data. All they need is to have the approval for the equipment, because the equipment they have already licensed. They have been licensed to use some microwave equipment on specific frequencies. Also for the distribution on different frequencies. Here they are requesting to operate on new frequencies. They will have to apply for approval for those equipment. And so far we have approved 2 companies. 3 are under study now. And once the others you will have, so 2 have approval for the equipment, and they can start building in the soonest delay at their convenience. And the 3, once we finish the study, will approve their equipment and they can start building their networks. I hope I answered.
Thank you, Antoine. Actually, and we're lucky to have representation from both companies that's been approved. So maybe I'll hand it to you, Ali, to talk a little bit about your deployment and highlight some of, potentially success stories or challenges that you face.
Sure. Well, we look at the IoT network. People today are talking about improving efficiency, reducing costs, better managing resources, being more environmentally friendly. And all this requires a set of sensors and actuators and a brain. What we are trying to do at GlobalCom Data Services is to create the neurons that will connect those sensors to the brain so that people can analyze the data and achieve their goals of efficiency and cost reduction, etc. For this, the biggest challenge was the choice of the technology, the neurons that will carry all those packets from the remote devices up to the brain. We've looked at all technologies that have been mentioned in here. And again, there is no one technology that answers all needs. So we had to look for a technology that answers at least 70 to 80% of the needs that we are thinking of. The technology we chose was the RPMA by Engine, which is a US company. Unfortunately, it hasn't been mentioned throughout the, all the day because people still don't know about it. The advantage of Engine is that they took like 6 or 7 years of research. They did not go to the market. They focused on research and looked at what other technologies did not cover to make sure that they include this in their technology. So they answer the capacity issue. Today, their access points, for example, can handle at least 250 to 1,000 times more messages per hour than any other comparable technology. In terms of coverage, they've done some tests in the US, for example. They can cover an area which is comparable to the Lebanon area, which is around 10,400 or 10,600 kilometers, square kilometers, with only 35 access points. I'm sure we cannot do the same here in Lebanon because we have other constraints on the amount of power that we can use and the geography of Lebanon with the mountains and etc. But the coverage per access point is big. And this is important because it affects the cost. If I'm going to serve 5 million devices and I'm going to need to install 500 access points is one cost. And if I need only 50 access points, it's a different cost. And the more we reduce the cost, the cheaper it will be for those devices to be connected to the network. And it would be more cheaper for the solution builders and the customers to benefit from such a network. Another concern, which is extremely important, is security. So the more you go with security and encryption, the bigger you need a packet size. Some technologies have a very big packet size, others use a very small packet size. The advantage of RPMA is that they use a variable packet size. So whenever you need a small packet size to save on battery and time to transmit and latency, you can do this. And whenever your application needs a large packet size, you can also use the same technology. And this is very important, for example, for the over-the-air OTA firmware upgrade. Many technologies don't allow you to upgrade all the devices in one shot from the same network. And a third advantage was the two-way communication. Many technologies just try to transmit once and twice and 3 times, hoping that at least one of the 3 packets transmitted is received, whether it's a data collected from the field or it's a command to an actuator to take an action. With RPMA, we have a two-way communication and we have an acknowledgement. So the device has to say that, yes, I received your command so that it, and I have executed it so that I don't send the command again. I would send the command a second time, 3 times, 4 times, 7 times, let's say, but then I would mark that device as defective because it is not answering. And I will tell a team that to go and physically check that device because it's not normal for this device not to answer. That with many other advantages that we've seen in Engine's RPMA. So that's why we chose this technology.
Thank you. Thank you, Ali. One more question for you, Ali. Like, I'm positive a lot of questions in people's mind. Are you live? Are you taking orders? Are you ready to take to install customers?
We are almost ready. We're just waiting for one piece of equipment. We already have the access points. The servers are ready. Everything is ready. The training has been done. We're just waiting for one piece of equipment to arrive to Lebanon, and we will start deploying and we'll start a proof of concept. And one thing that was mentioned in one of the morning's panels was in the universities to try to come up with projects between different faculties. And this is something that we have already proposed to 2 universities, and we will be glad to propose to other universities. One of the things we proposed, once we have our network, is to help students. Let's say we take a group of students from the agriculture faculty, and another group from the computer and communication engineering, and a third group from the computer science faculty, and we give them a project to work on and to come up with a real life situation to which they can provide a solution based on a nationwide network that we will be offering, using sensors they feel or they think are of benefit to this problem they're trying to solve. So this is something that we will be also encouraging once the network is ready, because internet started in universities, and in Lebanon, internet started in a university. We're talking to many customers, and the take-up is slow. So unless we show them what we can do with this technology, many companies will stay reluctant about adopting an IoT solution to prove to them that this can be very helpful and can reduce their costs.
Thank you. Maybe Jubran, like I know you guys also, I guess you get your license approval by the ministry and you started your deployment. Can you give us a little bit of insight where you are in your deployment stage and going to live, and any other success story you want to share with us?
Yes, of course, sure. Well, in the last years, we started to feel and sense the real interest in the Internet of Things from the industry, from utilities, from several segments and sectors. So we thought about it, and we realized that it's a good opportunity for an additional stream of revenue for us. And so we started to search and look for a suitable solution for the Internet of Things. And for us, we found out that LoRa is a suitable solution for, in our case. As Ali said, some solutions are suitable like 70% or 80%, but the choice of the solution, it depends on the status of each company. For us, LoRa is suitable because we have a large number of sites that are already there and deployed. LoRa, it has some characteristics for the long range. It's suitable for long range. LoRa is suitable for the devices that are operating on a battery. The ecosystem of LoRa is very large. You can find all kinds of devices and sensors, and the prices are cheap. So we started to do some testing, some experiments on LoRa, and we found out, for example, that in the dense urban areas, you need to have a gateway every 800 meters or a kilometer in order to secure and to have deep indoor coverage, which is essential in some applications like for the metering, smart metering, for water, etc. Soon, hopefully, we are going to start our deployment in order to cover the main areas of Lebanon. Our vision is that we should offer a complete solution from A to Z and not just offer the connectivity. Connectivity alone is not very attractive. Our customers or partners, they are expecting from us to offer them the full solution with data analytics, with the dashboards, databases, the whole ecosystem. So the good approach is to offer the full solution and not just to focus or to offer just a single part, like the connectivity. And we would like to thank the MOT for facilitating this and for allowing us to import and to test LoRa
that's it.
Thank you, Jubran. Marc, I'm gonna, I kind of heard earlier from Antoine that you were one of the first one who did some of, I guess, pilots, and I guess you participated in the RFPs, but also I saw outside and get the opportunity to see some of the devices you're working on. You want to give us your perspective on the industry?
Yeah, so as a system integrator, so we were involved in two ways. The first way, we were participating in the RFP to build a nationwide LoRa network a couple of years or 3 years ago. And I'm very happy and surprised to hear that you're launching it again in 2 months. So is it like written in stone? Yeah, it's a commitment? All right. Okay, we'll gear up. And the second perspective is that we wanted to offer our customers the ability to build or to solve business problems or to enhance business processes by utilizing IoT technologies. So, and this is how we partnered with OGERO to develop this POC of a smart city. So we did it in an area of Bitmisk, and we did the full story. So we covered applications like smart metering for water and gas and electricity. We covered the utility and the power management for the management of the city. So the management of the fuel tanks, of the generators, of the water tanks, and all the infrastructure which is needed to operate the city. So although this compound or this gated community was operating very well before we started, it's interesting to see how once we started to deploy, how they adopted the technology. And as a matter of fact, they adopted it in a very quick way. So for example, just to cite a small story, Bitmisk is in an area called Atshane, which in Arabic means thirsty. So it's an area that that has water problems. They take the water from down the valley, from a source down the valley, and they pump it to containers which are on the top of the mountains and then distribute it to the tenants. And the way they used to do that, every morning there was a guy in a truck on a dirt road that used to drive down the water valley and then, enable the pump, wait for the guy on the top of the mountain to tell him that it's full, and then, turn off the pump. And the day where we installed the sensor on the top with the actuator on the bottom, operated by a developer on his, HTML page, he was surprised to receive a call from the technician who actually drove the truck, telling him, please enable this, just enable the pump. So these are the small things that facilitate, but one of the other important things is the automation of their invoicing, of their collection, the detection of leaks, and there was a presentation by the president of Medco who was talking about fraud in fuel, and so they were able, for example, in Bitmisk, to detect how fuel was being utilized, especially for the generators, and how it was refilled, everything electronically and digitally. So it was a very, very nice POC where we learned lots of things. We learned first that customers expect, like you were saying, Jubran, an end-to-end solution. So they don't want to get into the details of every part. An end-to-end solution means that first you need to understand the sensor. So you need subject matter experts in every vertical, in energy or metering, etc. And then you need the IT stuff, the IoT nodes, the IoT gateways, then the connectivity, which was covered by OGERO, meaning in this case we use LoRaWAN. And then, the cloud, the platforms, the database, and all the portals used for the application. So when we build this, we realized that if you wanted to go and deploy to go to the market, we cannot do it if the central element, meaning the IoT network, is not present. And in my opinion, this is why we did not see further developments or similar projects. So without the presence of an IoT networks, LoRaWAN, NGNU, or any low power WAN network, you are restrained to IoT applications which are bound to technologies like Wi-Fi or 3G. And we know that these technologies are technologies that require power at the sensor. So this is why for the past 3 years, the IoT adoption in Lebanon has been very low and limited to this type of application, power-hungry applications. And I'm very happy that today you have at least 2 networks that are going to be deployed in 2019. And I think it will be probably this year, I mean, maybe by the end of this year and 2020, where we will see how IoT will bring value to the Lebanese society by digitizing all these things. So we're talking about smart city, and we see already many applications in the agriculture space and urban mobility. And I'm very optimistic about this starting 2020.
I must say, and maybe I'll bring a little bit of perspective from living in North America. The IoT hasn't taken off as much as people expected. We start seeing some deployment. A lot of us as technology enthusiasts, we really would like to see it right away. We see it today.
Yeah.
But I must say, like I would say, and I know James in the morning cover it. The adoption has been slow, but we've seen traction, and we start seeing some good traction. So I'm happy to hear that they've seen similar traction starting and having operator in place. I think that's a key important elements for us to start materializing this technology. With that being said, I would like to open it for questions from the audience. Any questions?
So while they are thinking of the questions, I'd like to confirm what you said in Barcelona. Actually, I met some people from Orange in France. And they were complaining about the same thing, slow adoption. So they built a nationwide network of low power WAN, LoRa, or NB-IoT, and the customers were not coming. So the customers, they were just playing, testing, trying. And finally, 2 years later, in France, which is considered more advanced society, at least digitally than here, they just signed and announced the first deployment of connected water meters, 3 million water meters. So yes, it's taking time to get adopted. Excellent.
Yeah, excuse me. How would the service be built to the customer? Say you are talking about building a LoRa infrastructure. How would it be built? Yeah, the billing process. How much would it cost?
All the services that are created by the Ministry of Telecommunications and OGERO has to be built according to a decree by the Council of Ministers. So, but we have kind of a draft for that. Until it is approved, it will be published. But the draft is something like maybe 500 Lebanese pound per month per device. Okay, so it's something it's going to be very cheap at that level.
Okay, practically, how would this be implemented? Say we are a company and we are including LoRa technology in all our controllers, and our controllers are being sold locally or outside the country. Would that be paid at the customs when we import the devices for LoRa, or at the time of deployment?
If I understand it well, all the products when they are imported, they will have to be, the document has to be sent to the Ministry of Telecommunications for approval. Otherwise, they will be held at the customs. So any telecom equipment has to go in this process. But if I understand it well, and you wanna sell your equipment in Lebanon, you need to have a license to become a LoRa user. Okay, it's not a license like in a subscription. Okay, the subscription will be related, as I said, it's according to the law that will be released. But in the draft, It depends on the volume of data, number of devices. So there will be different plans for different users. Either it can be an R&D center where you can ask for a couple of sensors, or you are a company that want to sell services, and you can ask for any number of devices.
I see, but if we are a business-to-business company and we are selling, let's say, controllers for elevator companies, and the LoRa is on the controller of the elevator, and this elevator will be used by an end user, but the company servicing the elevator is an elevator company, which is a different company. Here is the complexity. How would this be sorted out?
As I said, we'll be selling like subscription. If you have a devices, those devices has to be subscribed in our network, so that will allow this data to be transmitted from our servers. Okay, so any licensed, any subscription, they will have a certain number of devices, and on the other side, on the backhaul, they will have a connection to their server where they can collect their data. Okay, so whether it is a B2B or B2C, wherever, you need this API backwards so that you can pull your data from our servers.
Thank you.
If I can add something, Ziad, there are two elements in this. There is the actual connectivity between the elevator controller and the application, and there's the actual application. So in your case, either your company or a third-party company will sell the service of monitoring the elevator. So this company is going to pay OGERO for every elevator 6,000, no, 300,
500.
Yeah, so 300 Lebanese pounds every month for every elevator. But it won't going to add on top of it the charges. It's going to charge its end user for the application of monitoring. So it will be bundled inside the application.
Okay, thank you, Marc.
One more thing. As I said, in OGERO, we are going to build the network. Okay, it's for the connectivity. We'll connect the devices to pull the data from the devices, from sensors, actuators, wherever, to the database in our server. And then you can either come with your API and collect the data to your application, or you can use our cloud system, which we are working on now, so that you can host your application on our cloud. You don't have to take the data outside.
I have a question about the network that will be deployed. The frequency, it will be the same as the licensed company or different? You know that we have like 868 and 900 and 434. The frequency will be the same with like the same as Connect?
It's since it's an ISM band, so it is not licensed. It has not been, as I said before, it has not been licensed for Connect, for example, not Connect for waves. Okay, even for NGNU, for GDS, it's not licensed for them the 2.4 giga. It's an open frequency. Everybody can use it, and as I said, today, for example, the 2.4 is using for all the Wi-Fi, mostly used Wi-Fi devices, home devices. And the 868 is used for remote controls, especially. So when I said that we are analyzing the equipment, it is, we are checking that these equipments are compliant with the ETSI standard, which allow that all these devices can coexist at the same time. So there's no license for anybody on the ISM bands. We just allow, for example, waves to use these devices and those gateways on the 868. Okay, but for example, if we take the LoRa technology, each gateway can hold something like maybe 50,000, I think, something like 50,000 sensors, whatever the number is. If the number of sensors is going to be increased in an area, all of that we will need more gateways, okay? So that each sensor can report to a gateway.
Okay, thank you.
In the 868 megahertz band, if we take the example of LoRaWAN, we have multiple sub-channels. So now, for example, WISE has the approval to operate in this band. will you be using all these sub-channels? Because I want to go back to the questions, to his questions. Is let's say we will have a WISE network and an OGERO network. After we'll have all the interference problems between all the networks, since the channel, knowing the multiple access technique in LoRaWAN. So are you thinking of, let's say, managing these sub-channels between the different operators and or infrastructure providers? Yeah, my question for Jubran is, will you be using all the sub-channels? And for Antoine,
yes.
Do you think of managing?
Actually, the gateway of LoRa, for a typical gateway, it listens on 16 channels. And it works in a way of frequency hopping between those 16 channels. So the probability of interference is very low. I mean, of course, it depends on the number of sensors that are in a certain area and on the number of operators. If there is a way to synchronize and to organize the usage of the channels, we are ready to explore, to cooperate. Okay.
Any other question from the audience?
Sorry, but as I have said, since we're making sure that all the devices that you want to import or the real chipset that do the communication are compliant with the ETSI standard, this means that we have a very large number of devices. But since we cannot license a channel to a specific company, it is left open. Okay, so because even that the LoRa technology, when they came to the market, they came to a market knowing that this band has been previously used and heavily used, as I said, by remote controls. Also, small radio frequency remote controls operates on two major frequencies, which are 464 and 868 megahertz. Okay, but I heard someone saying 900 megahertz. 900 megahertz, it is licensed. It's an ISM band for United States. Yeah. So it is forbidden, in case someone would like to ship in some modules, on 900 megahertz, it's forbidden to be in the country because the main reason it will do interference on your mobile device.
The GSM, yeah.
So it will interfere on yourself. So that's why it's not allowed.
If I may add something, one of the strong points of LoRa is that it can operate below the noise floor. So it can handle lots of interference. For example, it can operate at minus 10 dB, and you can still receive and decode the signal and the packets. So it's an advantage, and it's a way of handling all the interference and the high number of sensors.
I have a question for Ali and Jubran. So recently we had to build our own IoT nodes, okay? And because to respond to certain requirements, we couldn't find anything in the market which was, specifically targeted to the business case that we were working on, and we had to build the IoT node. And we went through an interoperability, testing and adjustments with the type of gateways we were using and with the network server. I'd like to ask you, when you will deploy your network, would you have this type of facility, or will you just, provide with a catalog or list of pre-approved sensors that can be used on your network? Have you thought about this?
Definitely, we have thought about this. Today, the sensors and actuators manufacturers started to take into consideration the wide variety of transport technologies. So today, when you go to a sensor manufacturer, they will ask you on which network you want to use this sensor. And accordingly, they will manufacture the number of devices you want and plug in the communication device that has already been pre-tested and pre-approved by the technology provider. So today you can go to, let's say, an air quality sensor manufacturer and tell them, I want 10,000 sensors. And they will ask you want it to work on LoRa, on RPMA, on Sigfox, on NB-IoT, and accordingly, they will take that communication module, which has already been tested, plug it into the sensor, and sell you the sensor. So the majority of the providers today are doing this. There are still some exceptions where it is all built in, but it is not to the benefit of anyone today to go and purchase those sensors, because you will be stuck with a certain type of technology, whereas with the sensors that will allow you to change the communication module, even later on if you change your mind and want to move to a different technology, or do a hybrid setup. For instance, we might cover a certain area and waves cover another area, and you want to provide the solution in both areas. So you could buy the same set of sensors, but install two different types of communication modules.
For example, in the case of the gentleman earlier who manufactures controllers for elevators, how will it happen? You will give him like a module to integrate in his own chips, and then you will do the testing and you will adapt, or will you?
Yes, of course. Today, with engine specifically, with RPMA, they already manufacture the communication module. So everything, what he has to do is order like 1,000, 2,000, 5,000 communication modules, put them in stock, and every time he manufactures a device, he just needs to plug in the communication module.
Okay, clear.
Okay. As I mentioned, our aim is to provide a full solution from A to Z, should be end to end, and the device or the devices are part of such a solution. For sure, we will have a list of devices, commercial devices that are ready for usage, but we know and we are certain that in some cases we will need to create and to manufacture and to customize a certain device for a certain application or certain customer, like this gentleman. For that, we have established a research and development department at Waves, at Connect, in order to start to design and build specific and customized devices and sensors for certain applications.
Any question from the audience?
Hi, Ahmad Diab, UNDP. I have just a question. If we can clarify the issue of licensing. So the companies are licensed in a way, but in order to install a nationwide network, there is another separate license that must be attained. That's my first question. My second question is regarding that national network. Can it be, will it be RPMA based, LoRa based, or is this study going on now? And when do you think we will have something on the ground in terms of time? Thank you.
As I have said, for the second questions first, it is that the network will be based, the RFE will be based on LoRa technology, because this is what we have worked on 3 years back ago. So just now we are reviewing our tender, we are updating, especially on the security section, because security in IoT is taking a large work these days. So it's going to be based on LoRa. Okay. For the first question, to work or to build a network in Lebanon, okay, a wireless network, you need a license from not from the Ministry of Telecommunications, from the Council of Ministers. So as I have said, we have 8 companies that has been already licensed. The last ones were in year 2000. Between 95 and 2000, we had 8 companies that has been licensed to have a wireless network. So those companies are the only one, as of today, allowed to build IoT networks, because they have data networks license, and IoT is like a small packet data size. That's why they can do it. All they will need is just to approve the new equipment to be used. Okay? Even whatever equipment they want to use in their network, a new wireless equipment, it has to be approved by the ministry. Approval will come for the equipment, the frequencies to be used, everything related to it. Okay? Since we are still in a closed system, until it is privatized, the regulators, the TRA, will decide how things will evolve from that point.
Thank you. Excuse me, but also, like, do you have an idea on the timeline? So when can we expect something physical on the ground?
As I have said, we hope to launch the RFP in June, July, and we need something like 3 to 6 months to start building on the ground, because you need 3 months, like 1 month or 2 to validate the winner, and after that 2-3 months to ship the equipment in. And since it's based on LoRa, the deployment is very fast. Something like less than a day, maybe 2 gateways per day can be easily installed.
I just want to add, the ministry's network, when deployed, it will be based on LoRaWAN, and Wave's network will be based on, most probably on LoRaWAN. But there will be more than one network. So we will have our own network that will be hopefully nationwide based on RPMA, but there will be other networks, the ministry's network, Wave's network, and maybe another provider's network based on other technologies. So there will be multiple networks covering all Lebanon.
So thank you. And we're going to wrap up the session here. I want to thank the panelists for joining me up here, and I also want to thank you all for staying with us. I know we extended by half an hour, but thank you.
Thank you.
Thank you.
Thank you, Antoine, Aoun, Jubran, Ayan, Zogheib, Marc, Nader, Melhem El Helou, and Raymon Lahoud for this practical discussion. It's time to move to the closing session. I will pass you over to the coordinator of organizing committee and my colleague, Professor Marc Ibrahim. Marc, the floor is yours.
Yes, okay.
So IoT Lab 19 هي consolidation ل IoT Lab 17 بركي بأول اديشن كنا أول مرة عم نشوف IoT community عم تعرف على بعضنا من وراها صار في collaborations إن كان بين أفراد أو شركات أو حتى نحن بين الجامعة وبين some companies مثل ليباتيل ماهر هون اشتغلنا معه على البي او سي بكفريا. نتمنى انه اكيد كمان السنه اكيد في وجوه جديده في سبيكرز جداد كمان بركي بيكون في كولابوريشنز جداد للسنه او السنتين اللي جايين. البروجرام كان ديزايند هالسنه الاكتيفيتيز تبع اي او تي لاب كانوا ديزايند بطريقه تو فولفيل ذا ميشن اوف اي او تي لاب اللي حكيت عنها بالاول اللي هي تو برينج اي او تي نوليدج and to Lebanon بنفس الوقت position Lebanon the IoT map. بتمنى انه من خلال هاكاثون امبارح من خلال اكزيبيشن اليوم ومن خلال الكينوت سبيكرز والكينوتس والبانلز اللي كانوا عندنا كان في 3 بانلز من خلال البرزنتيشنز تعلمتوا اشياء جديده شفتوا انسايتس جديد عن اي او تي واكيد كمان يمكن قدرتوا يو ابريشيت الانوفيشن اللي عم بيصيروا بلبنان بالاي او تي فيد. حابب اشكر السبونسرز اكيد اللي هن بفضلهم قدرنا نعمل ايفنت فري اوف تشارج واوبن للكل يعني لكل حدا حابب يكون موجود اللي هن بنك عوده جي دي اس كونكت اوجيرو بي ام بي داتا كونسلت بوتك وباريتك مانجمنت فند. ميرسي لهم. وقبل ما اقول لكم ميرسي لكم بدي بس لكم انه you've been tracked كل هذا النهار. زميلي الجيك سامر لحود، دكتور سامر لحود، كان عم بيلقط كل الماك ادرسز على الواي فاي ديفايس اللي شايفينه هون. It's an IoT device وزنه بعتقد كم جرام. It's a TDCO device. مثل ما ملاحظين بقلبه في لورا انترفيس وفي واي فاي انترفيس. فالواي فاي انترفيس كانت عم تتسمع على البرو ريكوست تبع كل السيلولرز تبعكم، وعم تبعتهم على اللورا انترفيس على اللورا سيرفر تبعنا. ومثل ما شايفين هون على الشمال في number of devices detected. كل الديفايسز اللي عم بيقطعوا حواليه كانوا عم بيترقموا هون، بس ما تعطى لهم it's GDPR compliant. ما في ولا ماك ادرس stored على السيرفر تبعنا. It's just for counting devices. ميرسي كثير لكم. Stay tuned. رح يضل عندنا activities related للاي او تي. ميرسي.